So I want to say it's kind of funny. I don't know whether scheduling deliberately put after the aviation talk. I'm here from a travel company. Also, it really did get me thinking that last talk. What am I about to talk about? Did I consider those? So, interesting there. But just to start, so Skyscanner is a global travel company. We have 160 million users, 52 countries. And a lot of what we do is around data, whether that's data to improve our product, find the best prices, using that to help our partners. And as I go through this, just that's kind of the scale that we're talking about. So when we talk about data, there's a lot of it. Now, a little bit about myself. So when I started at Skyscanner a few years ago, I started as an app engineer on the team, leading some teams there. I kind of got involved in like a data emission SDK, so how we send our data out of the app to our different data platforms. And that kind of evolved into getting into this ingestion side, the processing on the data side. And so for purposes of this talk, I'm going to be focusing on this. Now, I operate in a few other areas with sort of other boxes, but this is really what I'm here to talk about. And the other thing that I had was in my decade plus as a tech lead, I'd actually been, I say lucky enough to never lead like a P0 or P1 incident, but I'd sometimes be at these similar conferences, listen to talks, and I was like, sometimes it actually sounds good to lead it. Like you get a lot of learnings. A lot of the talks that we've had here today already that we're going to have are about how you can take these things and make them better. I've always admired people who have been able to come share this, hey, here's how everything got messed up. I think we've all read some of the great postmortems, blog posts, conference talks. So I kind of was like, it kind of sucks that I've never led an incident, like a huge incident. I've been tagged in, but never led. I was like, I don't know how I should feel about that. But obviously, you can never expect when these things will hit. And so I'm here to talk to you about what we called internally our iOS data incident. So this all started, as things normally do, as sort of the Monday morning, logged into Slack. And we had this fairly innocuous message at first. Nobody was tagged. It was just a question from sort of one of our data analysts that was just saying, hey, looks like there might be an issue. Something doesn't look right, down significantly, but we're not sure. And there was sort of some comments. Maybe it was like a marketing campaign that was paused. Maybe something happened. But what did this lead to? So from this one Slack message, over the next sort of week plus, we opened an incident late in the afternoon. I became the incident commander, kind of figuring out, hey, what's happening? What's going on here? We discovered that all of the data emission was broken in our latest iOS release. So we have sort of millions and millions of events that were literally just missing. They weren't being sent. We narrowed it down to a change. So, okay, we found what happened. We shipped something bad. We released a fix, and we found the second issue, which was, oh no, all of the failed events had actually remained cached on the device and were sent en masse at once. So it's led to a huge dip, followed by a huge spike in our data sets. Our consumers weren't happy. This isn't just internally, this is externally. Our partners use this data. They were also wondering what happens because we didn't predict this. We couldn't even tell them because it all happened at once. Now, the good news at the end of this, we're actually able to use some metadata to backfill our events. So we eventually did end up with sort of a smooth line, just about worked out, but it was a very stressful 7+ days. And I use this graph because this graph kind of shows multiple things. First of all, this is literally what our data looks like. So huge dip, huge spike. Also could represent the roller coaster of my emotions as I was dealing with this. And I was going to say could also represent my heartbeat over time, but I'm not a doctor, so I don't know if that's regular, irregular, or not. But it sort of really did show this is what we were dealing with. And this also, as I said, impacted external partners, all of our internal experimentation, which couldn't return results. So there was a lot going on. So once we got through this, and I did start asking some of the questions. Now, even for myself personally, as I said, we're in the incident. We focused on getting through things and working out what needed to be done, everybody pulling together. But then I was like, this kind of sucks for me. And I know just because of my internal dialogue, but this is what I showed I'm sort of responsible for. And I'd spent years working with the team, some great engineers, and we thought we'd built up resiliency at all of these points. I was like, where did this fail? We've built up all of these systems, and how did none of this happen? So sort of moving on to the questions, these were sort of some of what we started coming up with, and I'm going to walk through in this talk today, because I think it's just really interesting to see how all of these things can come together. So we started like, how did the original change even break the emission? What actually happened there? But then, okay, but why wasn't it caught by testing? And then why didn't monitoring catch it when we were rolling out the release? Then why didn't our data consumers detect this as well? Why did it still take 6 days to manually detect? And then why did we take so long to raise an incident when we found it out? So I'm going to go through some of the learnings. Hopefully it will be kind of interesting to you. A lot of things that we found out, again, just showing how these complex systems can go wrong. So we start off, how did the original change break our data emission? Now, I don't know if we have any mobile engineers having the call, so I'm just going to run through this very quickly. It's a lot of text. I'm just going to kind of skim through it. But basically, we have an internal SDK that I'd worked on, as I showed at the start. And we deliberately centralized this code, so whenever one of our engineers wants to emit an event, we make it very easy for them. So one line of code, send event, send some parameters, you're good to go. But we also have some of these transformations where, for example, we want to apply a consistent timestamp, a consistent header to all of the events. And this can also be handled independently. And what we had some sort of dependency management code, brought these all together. You can write something up here, something over here, and it brings it together. So kind of looking like this. So you can see on the top, this is how our events get processed. On the bottom, how the SDK handles these, and they all get added to a queue that eventually gets flushed when all the transformations are applied. And what happened? So we made a completely unrelated change in our dependency management code. One of these unrelated PRs, sort of a very innocuous title, like cleanup, something like that. And nobody had noticed this. And it impacted one of these transformations. Unfortunately, and this comes on to the relevant bit in a minute, it was also written in legacy Objective-C. And because this was a sort of required transformation, all the events in the SDK were pending, nothing was sent. And then once we released the fix, unknown to us, the queue then processed them en masse as the user updated and led to this huge spike. So if we look here, basically this whole bottom row wasn't happening. That's how the events got stuck. And what's funny, when we talk about the fix, again, I spoke about looking at these postmortems, hearing other great incident reports. And I always love it when you hear, hey, the fix was some really low-level thing that was happening, maybe something on the iOS platform that caused some really tricky thing. Unfortunately not. Our fix was one line of code. It was literally setting a variable that had been missing. Unfortunately, Objective-C doesn't complain. It doesn't throw a null pointer exception. It doesn't fail at compile time. It just literally lets you run the code, silently fails. And I'm very glad that everybody's moving to Swift. So we then have a lack of knowledge around it as well. Like, how did we not know what was happening? As I said, we had the dip, we had the spike. And, we start to look in, and this was a little like the human errors that we were just hearing about. So we did have a lot of engineers had since left the team. One of the things we found, and again, it's the thing that you don't think about until you happen. So we had engineers who write documentation, and they're engineers. So they do a lot of, hey, this code is really complex, so I've explained it in the diagram below. And we'd migrated to a new documentation platform. Certain diagrams had been lost, so you had this diagram not found, which is not useful when you're trying to understand or debug what was happening. And so we go on to the next question, which was, okay, well, why didn't our tests catch this? We made a change, we pushed something, that's fine, we broke something. And it turns out we didn't have effective automated testing. And this one was actually pretty tough to go through because we'd actually spent a lot of time trying to build up effective data emission tests. And we actually thought we were really strong on this. As I said, data is a key part of our business. And so we had written alongside this SDK, this internal testing framework where our engineers could say, hey, I went to emit an event. Did it get processed correctly? Did it go through? But what we had done in terms of trying to make this efficient, reduce test running times, get things working, it only tested up to the point of adding to the queue. So we could inject fake implementations and all of these things. And it meant that technically all of the tests were green because the tests were being added to the queue. You could verify that everything was working as expected. It just failed after that point, which was not good. And we then had lack of automated checks. Again, the things that in the moment you don't think about until it comes back and sort of bites you like this later on. So we have a bunch of automated code quality tooling, lint checks, static analysis, all of this, but we disabled it just a few months before this incident. That's because we'd made the trade-off. Hey, we're getting really long CI times. It takes a long time to run against just legacy Objective-C. Is it worth it? We did all the maths. We get X many hundreds of builds per day. If each adds 6 minutes to the pipeline time, that's X, $100,000 of engineering time over the year. And we removed it. And of course, we get this bug. So that was fun. And so we did have, some learnings here around need to invest in the tests. Documentation needs to be regularly reviewed. We put by new starters as well, because they're often the best people to come in, ask the questions or find these gaps. And also we took an action to try to move our diagrams and our docs closer to the code to prevent this kind of platform migration impacting these. But we then move into this. So again, we had all these questions. We were like, okay, that's fine. We can understand. We didn't get it caught by test. Something got shipped. It started rolling out. It happens. But why did none of our monitoring detect this? Why didn't we actually start getting alerts straight away? And again, this was actually kind of, again, another human point where we had a dashboard which showed this kind of dip you can see above. But what was happening was nobody took the responsibility to check it as part of a release. First of all, because this had never gone wrong in years and years. So over time, like you have it and then people are like, it's fine. I don't need to check it this release because it's been fine for the past 100 plus, 200 plus. But then we also had this, oh, well, I thought so-and-so was checking it. Oh, I thought so-and-so checked this as part of a rollout. So we took some learnings here, regularly reviewing our dashboards, and consider deleting. We sort of tried to put like maturity and health onto the dashboard so that we could start tracking this. But then again, so we still go through, and these were all the questions we were asking. I was wondering to myself, I had folks as part of this, I was like, but then why didn't our data monitoring detect an issue? And what we found was that, we do try to operate at Skyscanner very much. You emit data, you own it in the first instance. And again, this was something we'd actually thought we were doing pretty well on. We thought we had like an alert tooling that would run across our data sets, that would get these things working, that would start getting flagged. But the problem was engineers, we'd done sort of, we call them like turbo lift PRs, like mass PRs, which just say, hey, merge this PR and you get your alerting set up. And they're kind of that, please review the thresholds, but we set some default values for you based on the tooling recommendations, so just go. And it turns out that default configuration was wild. So again, this was like a chat GPT. I just kind of generated it quickly, but maybe what you'd expect, kind of like a 5%, 10% threshold where you'd start to get alerted. And it turns out when we investigated post-incident, the default threshold was set to something like this. So literally, it just automatically said, if it's within this huge variance, and of course, it only triggered once the events had almost dropped to 0. So not useful at all. We thought, hey, we had this, it didn't work. So again, sort of, we then looked data monitoring side, we had very similar issue. If we take this out of just our iOS, we'd think surely when we get some of these key data sets, we'd start to notice this drop. But again, problem was we never configured these alerts by platform. So the drop in iOS, if we look at it, we have data across Android, iOS, web, mobile web. And during the first few days of the incident, it just looked something like this. So we could see a drop, but again, thresholds weren't correctly configured, and so we didn't detect it. So again, really key learnings, mainly around never relying on the default alert settings, always making sure to test these things out and trigger the alerts to ensure correctness before they go through. And again, so I feel like these questions will build upon each other. We start seeing these failure points as like, okay, we can kind of justify each level. But again, it's like, why did it still take 6 days? Okay, the alerting failed, but surely somebody should have been looking at this data. And as I said, we normally don't manually monitor this data volume. We expect all of the automated checks we just spoke about to be in place. But what was interesting, and again, it goes down to sort of assumptions and like outside of our control, when we'd released the app, I think we released it on a Tuesday. And for the first few days, for those of you in mobile engineering, you will know, you have this slow adoption curve. Apple does staged rollouts. Just because you deploy to the App Store doesn't mean everybody gets it. Everybody waits to download. And we actually saw a huge spike over the weekend, which was when more users were opening the app, triggering background downloads, updating it. So when we saw the real impact of this incident, it only started probably around Saturday morning, and it wasn't picked up until Monday because we didn't have, as we spoke before, the sort of alerting or monitoring in place. So again, key learnings here, really paying attention to our app adoption curve, understanding these sort of human factors, understanding it might not occur when we expect it to. And the final question we had, given all of this, the journey that we've gone through was, why did it still take so long? And I say so long, I think the incident was, the Slack message I showed was sent Monday morning. The incident was raised Monday afternoon. But as all of us know, and who have worked in these incidents or worked in these companies, that is a very long time to go. Almost a whole working day without actually picking up on this, without someone doing it. And again, it was one of these, the data set it was spotted in was sort of this end. So we'd gone through multiple sets of processing, multiple data sets being combined together, taking these events and these events. And at first, it was this, folks were thinking, hey, well, maybe it's this data set that's the issue because this data set feeds into this data set. And, but, oh, well, maybe I know there's been issues before with this. And everybody was kind of talking to each other because I think everybody was a little scared. Hey, let's not call an incident just in case it's something really obvious. As I said, like, hey, a marketing campaign was stopped. And so we expected this. So we did take a key learning. If we'd opened triage incident, if we'd gone through this sooner, we could have got the right folks into the room who could have looked at this, because we only eventually got to this when it was like, no, this is affecting enough to justify raising the incident. So let's summarize where we are. As I said, I've gone through a lot of questions, a lot of what we went through. And as I said, this is why I thought it was like the really interesting combination of one of our engineers made a change to some legacy Objective-C code. Fine. Automated checks had been disabled for the code and it was missed in review. Automated tests written for this emission continued to pass. During the rollout, the dashboard checks were missed. Monitoring didn't fire. When this data was then ingested, the alerts didn't trigger because we had wildly misconfigured thresholds. And so at every point of this, our tooling looked green or looked good. So you can kind of see how it was this perfect storm where we then ended up with the Slack message and kind of really led to a lot of the learnings that we'll talk about. So I'm at a conference that even has a "In the Age of AI" tag behind me. I couldn't stand here without briefly touching on this. And one of the things I do want to call out where it actually really did help was a lot of the data analysis. So I said we had actually hundreds of affected data sets, technical and non-technical consumers. The ability for them to actually write natural language queries to understand was a huge help for us. We didn't have to be running SQL queries, going into our data platform. They could just say, my data set is X, was it affected by this incident? And they could get a yes or no response. Really, really helpful for us. Where it didn't help, so the monitoring, I touched on these thresholds earlier. A lot of these were supposedly AI-enabled monitors that were supposed to intelligently detect these things. They didn't. So that wasn't very helpful for us at all. And even the debugging. So we went after the fact. I said it was some legacy Objective-C code. We fed in the changes into a bunch of models, said, can you find what's wrong? Asked it to review. Not a single one caught it. Now, I understand everything's moving very quickly. I have to say, even for myself, I'm very excited to find out, we do use Instant IO. If their SRE would have caught it, I think I'm going to test it when I go back. But at the time of the incident, that didn't help us out. Do have a few things, though what did go well, I'm here representing Skyscanner, so I'd be amiss if I didn't talk about, some of the communication we had. Really great that we had this sort of no blame culture, everybody pulling together. We did have the instant Slack channel. We managed to keep things centralized. Again, the no blame culture and collaboration on actions, everybody pulled together, which was great. But what were these actions? I always think the interesting part from these incidents isn't what happened, it's what happened next. How do we take this and learn from it? So we had our corrective. Of course, we fixed the issue. We backfilled our data sets, which was great, kind of mitigated the impact. Preventative, we looked through a lot of our alerting, updated our documentation. But then we got into the strategic. And this was, I think, really interesting. So again, we went through all of our alerting, basically said the thresholds suck. We can't rely on them. We have to do an audit of everything that we have. But also, and this is one line, but it's actually pretty huge for us internally, was removing all of our legacy Objective-C code. Now, our engineers back in our different offices are working on this as we speak. This was something that had been spoken about for years and years. We had the long tail, just a tiny percentage left. but it was underpinning some of this. And the fact that this incident has led to this, I personally think is a huge win. So just to wrap this up, this was actually a really fun one. I say fun, now I can reflect back on it. In the moment, it wasn't. Think of that sort of graph. But, hopefully it just shows how systems are complex. All of these things can conspire against you. We thought we were very mature in all of these areas. Everything just happened to hit at once. But we've learned a lot. We've taken a lot. I'd be very happy over lunch to speak if anybody has any more questions and wants to find out a little more. There's a lot that I couldn't fit into the 20 minutes here. And now I can say I've run my incident. I don't know whether I want to run another one again very soon. I'm happy to say that at least I've been up here speak. So, thank you very much for listening and thank you for your time.